So, friends, welcome to this lecture series of geomorphology, and today we will continue with this glacial geomorphology, mainly the geomorphic changes by glacier. So, what does it mean? This how this glacier changes the topography? As we know, it erodes the material, it transports and it deposits. So, that means we will find both erosional topography as well as depositional topography, and during transportation also in the way it creates some topographic changes, some depositional structures and erosional features are created. So, that will be discussed in this class. So, starting with the streams or the drainage pattern changes in a glaciated area. For example, if you remember when we were talking about this U-shaped valley and a V-shaped valley in this river system is generally created the V-shaped valley, but in glaciated sequence it is create U-shaped valley. If you see these two figures, here's river valley before glaciation and after glaciation. That means the river valley was a sinus form, but if you see after glaciation it's become straight, and here due to deep erosion there are lakes are formed, that is long narrow ribbon lake, then truncated spurs, then jugged watershed, then cliff like U-shaped valley, then wide and flat valley floor. So, all these changes that occurs in higher reaches and due to glacial erosion or this and mostly this drainage pattern is changed to deranged drainage pattern. Deranged drainage pattern, if you see here, that means the characteristic feature is no apparent pattern, haphazard. If you see this model or this figure, you see there is no particular drainage pattern, particular type of drainage pattern, no particular fashion of arrangement. So, haphazard arrangement is there. Streams flow with landscape left behind from a glacier. That means, as glacier erodes very deeply. So, it is very difficult to this river system or the channels to accommodate itself with a changed system. That means, it has to accommodate itself within this changed system by the glacier, because it takes more time to modify this changed system by a river system. So, that means the glacier, the rivers or the channels initially they accommodate themselves within that changed topography by the glacier. Water is from this retreat of glacier. So, here the retreat of glacier the water is supplied, and there are haphazard orientation, there are sag ponds, then the channels there is no fashion of arrangement. So, that is called deranged drainage pattern. Erosional topography by this glacier, it is U-shaped valley, this most prominent one, then hanging valley, lakes, then fjords, pattern store lake, sharks, arete, Roches mountain, then horn, then truncated spurs. These are these glacial erosional features. And if you see these models given in the right hand side, there are number of erosional features have been discussed here. The sharks, this pattern store lake, the horn, then arete, this glacial troughs, hanging valleys, these are given here, we will discuss one by one. So, U-shaped valley, that is glaciated valley are formed when glacier travels across this down slope, carving the valley by this action of scoring. So, here we are getting U-shaped valley, this is U-shaped valley is there, and the V-shaped valley is by the river. So, another is this hanging valley. Hanging valley means a valley formed by a small glacier that has a valley bottom relatively higher than this nearby valley formed by this main glacier or this trunk glacier. If you see here this glacier, it is a trunk, it is a tributary glacier, and this is the main glacier valley, and this is the tributary glacier valley. This is main glacier valley, and you see this tributary glacier valley is this much height elevation up at this as compared to this truncated glacier, this main or the trunk glacier valley. So, this is called hanging valley. So, that means it is hanging above this main glacier valley, it appearance like is that. Then fjords are nothing, it is the glaciated valley now occupied by ocean or this marine water. So, fjords are coasts formed by the submergence of U-shaped glacial troughs. These are this is the submergence of the U-shaped glacial trough. These are narrow inlet of the sea into this sea coast bounded by steep and high mountain slopes. The highest height matched by its vast depth too. Now, you see this is glacier valley was there, and this is marine, this is the tongue of marine water which is occupied, that means it is submerging by this marine water. So, this U-shaped valley which was earlier, this was this U-shaped valley also, the glacier was moving through this path, and now it is occupied by marine water. So, this is called fjord. Then pattern store lake, it is produced when water filled rock basins or bedrock depression produced by glacial flocking in the valley floor. It is one of the series of glacial lake connected by single stream or braided stream systems. Now, you see here, this is the path of the glacier which was moving, and after the glacial retreat there are number of depressions, and the depression is occupied, and it is depression is creating some lakes. And now, you see this lake, isolated lake, this is isolated lake, that is connected through a channel. Similarly, this is connected through a channel. So, these are the pattern store lake. So, pattern store lake, it is a typical pattern of glacial erosion or remove or this change or this modification of this parent drainage system by this glacial action. And this is a part of the deranged drainage pattern. These lakes are interconnected through single channel or braided channel system. Then sarks, that we have already discussed in earlier times also. Sarks, they are isolated patches or isolated valleys that is occupied by glaciers, and it is mostly it is circular shape. So, glacier that resides in the basin or amphitheater near ridge crest, you see it is bounded by the ridge crest, and the most sarks glaciers have characteristic circular shape with their width as wide as or wider than this length. So, these are these sarks. So, these sarks are there. Then arete, if you see these two sides, it is bounded by glacier valley, and in cross section you are looking, is cross section is like this. So, here is a glacier valley, here is a glacier valley, that means this side glacial erosion will be there, this side glacial erosion will be there. So, the remnant part of this hill that looking like a ridge separated by two glacier valleys, that is called arete. And horn means it is a glacier valley, remnant mountain, all sides it is bounded by glacier valley, that means junction of three or more aretes, it is called horn. For example, if this photograph you seen, this is one arete, this is another arete, this is third arete, and probably that side there will be another arete. So, at least three arete if mixed together, they are interlinked together, it is forming a particular type of erosional topography, that is called horn. If you remember, when we were talking about this erosional system of this aeolian system, that we are talking something about the star dunes, that means it is a junction of number of dunes together, longitudinal dunes together, and all sides it is that means wind velocity. So, that means it shape wise, if you look from this aerial view, shape wise this is similar to that star dune, but here this is due to glacier, that means here one U-shaped valley, another U-shaped valley here, and third will be here. So, three different aretes they are linking together at a point, and this part, this remnant hill, it is called the horn. Then Roche mountain, it is the otherwise it is called ship back, it is looking like the back of a ship, is a rock formation created by the passing of glacier. The passage of glacier ice over underlying bedrock often results in asymmetric erosion forms as a result of abrasion on the stoss side of this rock and plucking on this lee side. These erosional features are seen on scales of less than a meter to several hundred meters. If you see here, this is the glacial movement direction. So, here we have Stoss side and this is lee side. So, here is due to splocking and this is due to abrasion. So, here otherwise you can say this figure, this is Stoss side and this is lee side, and this type of erosional topography they are called Roches mountain. Then truncated spore. Truncated spore means, if you see the spore, when we, if you remember our classes when we were talking about this fluvial geomorphology, the erosion of river. So, where interlocking spores are there. If you see here, this is one spore, this is another, this is third, this is fourth. So, the interlocking spores are there. So, now if we allow the glacier to move within that, so it becomes straight. So, once it becomes straight, if you see here, this is a spore which is truncated here, this is a spore which is truncated here. So, these are similarly, this is a spore which is truncated here. So, these are these truncated spores here, this is a truncated spore, these are the truncated spores. So, that means once glacier is moving, it is removing these rock materials by valley side erosion, as that is why these truncated spores are developed. So, it is a spore which is ridge that descends down towards the valley floor or coastline from a higher elevation that ends at an inverted V shaped and was produced by erosional truncations of this spore by this action of either streams, waves or glacier. But here glacier at the glacier valley, at the U shaped valley, at the side of this U shaped valley, this type of truncated spores are common at the higher reaches. Then triangular facets, this is the part of this truncated spore where this spore truncates. This cross section, if you see, it is looking a triangle, it is looking a triangle, triangle, triangle. So, these are called triangulated facets. So, triangulated facets, not only they are the product of glacial erosion, there are a number of ways through which this truncated these triangulated facets can be developed. For example, suppose there is a fault here, I am putting a fault here and this is the fault plane, this is the fault plane through which these spores can be truncated and this type of triangular facets can be developed. So, there are number of ways through which these facets, triangular spores, facets and truncated spores are developed, but if they are confined or their location is at this U shaped valley which is not affected by fault. So, that means we can say in safely that these truncated spores and these triangulated facets, they are the product of glacial erosion. Then outwash plain, that means where the glacier retreats, where this fluvial system develops. So, that means it is more or less it is a glacio-fluvial environment. That means the retreat of glacier here, the retreat of glacier here, and here see these are this fluvial system, they are the channels, they are developing from the glacier, they are eroding here, depositing the sediments there. So, mostly it is glacio-fluvial environment, this is outwash plain, and many times this area is also that means restructured or it is rearranged, reworked by wind action also. So, this outwash plain, it is a vast plain which is in front of the glacier and it is defines this retreat of this glacier. As a result, this streams which are generating from this glacier, they rework the sediments, they transport the sediment, they rearrange the sediment along with some aeolian action. So, this is total called this outwash plain. It is a plain formed of glacial sediments deposited by meltwater outwash at this terminus of this glacier. As it flows, the glacier grinds the underlying rock surface and carries the debris along. So, these glacial debris, they are redistributed by the fluvial action, this is outwash plain. Then all those things that we are talking something about the glacier system. Now, we will talk about this glacial deposition system, that means by erosional system we have created some of these topographies and this time it is to discuss about the glacial deposits. So, that means those materials which are removed by this glacier due to retreat of this glacier in the abrasion zone. So, this material has to be deposited and this forms some of these landforms, that is depositional landform, that is here the first one is the till, or otherwise the deposit is called tillites. So, it is unsorted, that is important, unlayered, that is another important, that means no stratification is there, no layer wise arrangement is there, no sorting is there. So, that means as it is dumped like bulldozing action. So, this bulldozing action, all this material irrespective of its sorting, irrespective of its origin, so there will be no layered sequence. So, this material is dumped as it is, that is called till. So, till is unsorted, unlayered material deposited directly by a glacier. Landforms composed of till includes moraines, drumlins and glacial erratics. Glacial erratics that we have already discussed earlier, and moraines and drumlins, these are the unsorted, unstratified form of the glacial deposit. They are directly deposited by the glacier, not in the outwash plain. Outwash plain means that it is glaciofluvial deposits, but here it is the glacial deposit. Now, if you see these photographs, these are the material, there is no sorting, it is starting from the boulder through clay size particle, there is no sorting, no preferred orientation, no preferred layering. So, this material is called till. Now, we will discuss about moraine. The first, that moraine is any glacially formed accumulation of unconsolidated glacial debris that occurs in both currently and formerly glaciated region on earth through geomorphological processes. So, that means these are these moraines, that means if this is a glaciated valley and these are this region where glacier is moving, and here if you see at this end of this glacier we are getting some material, and at the, if this is the glacial valley is continuing, at the side of the glacier we are getting some material, and here is a model very nicely elaborating the system. Here this is the glacier and these are the material, there is moraines, and here the material is, here the material, that means each and every glacier by the side, at this end, at this middle where these two glaciers meet or moving side by side, at this middle part we have that deposits. Here at the side of this glacier we are having deposit, and here two glaciers meet, and here two different ridges they are also merging. So, depending upon this type of relationship, either they occur at the end of this glacier, they occur at the side of this glacier, they occur at this junction of this glacier, the moraines are named so. So, first this is called lateral moraine. Lateral moraine means these moraines or these deposits, they occur at the side of this glacier, that is called lateral moraine. Similarly, medial moraine means here you see these two moraines, two lateral moraine, here this is lateral moraine, this is lateral moraine, they are linking here and forming a single moraine, that is called medial moraine. The medial moraine means here two glaciers meet, as two glaciers meet, two different moraines they are meeting at this point and continuing, this is called medial moraine. And these are called end moraines. End moraines means where the glacial retreats, that means the glacier is retreating down. So, this end moraine occur, the end of this glacier these moraines are deposited, this is called recessional moraine, ground moraine, terminal moraine. So, that means depending upon its position with respect to a moving glacier or a dead glacier, these moraines are named, this is called moraines. And we have discussed these things, lateral moraine, medial moraine. Lateral moraines, these are this lateral moraine, they are laterally at this glacier, and this is a medial moraine because two glaciers that meet, and here two lateral moraines they are mixed, and this part is called medial moraine. End moraine, here the glacier melts, the ends its position, and this is called the end moraine. And another type of moraine, this is called dump moraine. Dump means it is dumped. So, a dump or dump moraine is a mound or layer of moraine formed along the edge of this glacier by rocks that fall off the ice. So, now here that means a rock fall from the ice. So, that means you say ice valley glacier is moving, on which this valley, it is the bedrocks, they are eroding, their blocks, they are also falling within that ice. If these blocks, due to movement of this glacier, these blocks are moved apart or they fall off the glacier to the side and forming this moraine, that is called dump moraine. So, it is a special kind of lateral moraine. The another type of deposit is called drumlin. It is elongated hill streamlined in the direction of ice flow and composed of glacial deposits. Each drumlin is a small hill. So, now you see here, this is small hill type, and if number of moraines they are forming here, this is called drumlin field. So, tending towards the egg shape, if you see this plan view, it is looking like a egg shape with a steepest slope and summit at this up ice end. Drumlins rarely occur single, and however, at these are found in the groups of swarms with the tapered end of each hill pointing in the direction of glacial flow. So, here the direction of glacial flow, this side is the blunt end and this is the tapered end, and this is called drumlin field. And if you look from this plan view, this drumlin field, it is looking like a basket of egg. So, that means you can place an egg here, place an egg here, place an egg here. That is why this is called geomorphological term, this is called basket of eggs, it is drumlin field. The clusters, if you see this aerial photograph, this is the drumlin field and a number of drumlin is there, and it is a single drumlin. This elongation may related to the speed and duration of this glacier flow and the resistance to deformation of the sediments at the core of this drumlin. Now, you see here, this mostly it is found in the sedimentary rock. So, here this is the basket of eggs are there, and its elongation may be related to speed and duration of this glacier. How speedily this glacier was moving, and how much time the glacier has taken to move, and this duration of the glaciation and duration of the glacier movement and the speed of the glacier movement, that defines how this length will be, length of this drumlin will be. This glacial erratics that we have already discussed about it, it is the foreign rock which is transported from hundreds of kilometers from this original position and due to glaciation, and it is falling an area which has no relation with the surrounding rock, that is called glacial erratics. Then all these things we are discussing about, either this moraine or this drumlin, this glacial erratics, that we are talking about this unstratified deposit. There is no stratification. However, here we will talk about this stratified deposit. Stratified, that means there is proper arrangement, proper layering will be there, but there is no layering, there are erosional topographies. So, stratified drift or this sorted stratified sediment laid down by glacier meltwater, often by braided streams. Landforms composed of stratified drift and deposited by the glacier meltwater include outwash plains that we have discussed about. These are these outwash plains, that means by melting of the glacier, the rivers they deposit their the rivers they transport and rework these glacial sediments, and different form of depositional topography, erosional topography are formed, that is called outwash plain. Then kettle, eschar, cams and bharvs. So, here outwash plain is also called sandur. It is a plain formed by glacial sediment deposited by meltwater outwash at this terminus of this glacier. So, here this is the terminus of this glacier, here this is the terminator of glacier, and now see the rivers are coming, these channels are coming up, there are braided streams are there. So, these streams they are depositing their sediments, these sediments were reworked, and this is called the outwash plain. Then kettle, if you see, this is a retreating glacier also create features, this is called kettle. A kettle is a small depression that is formed when chunk of ice is left in the glacial till. So, now you see that the mechanism of kettle formation, if you see here, this the ice sheet or the valley glacier which is moving, and at this ablation zone you see this chunk of ice is broken apart from the system, this is dead ice. Now, you see it is no relation with the parent ice sheet or ice body. Now, if it is deposited by, it is covered by sediment, after few times, if by the melting of this ice here, this depressions remain, the sediment collapse, the overlying sediment they collapse and finally forming a hole, that is called kettle. So, if you see this aerial photograph or the satellite imagery of this region, so these are these kettle lakes. Similarly, these are the kettle lakes. So, when the ice melts, the kettle remains. This continental glacier of last ice age left behind many kettles. Kettles often fill with water, forming small ponds or lakes, that is called kettle lake. Such lakes are common in areas such as Minosta, where they are covered with ice. So, these are these places where buried ice pieces were there. So, once the, and it is covered by sediment, once the ice melts, the overlying sediment that collapse down and forming this whole type or this pond like environment, pond like topography, and this is called the kettle lakes. So, a kettle is a depression or hole at an outwash plain formed by retreating glacier or draining flood waters. The kettles are formed as a result of blocks or dead ice left behind by retreating glaciers, which become surrounded by sediment deposited by meltwater streams as there is increased frictions. So, these are the mechanisms how these kettle lakes are formed. Then another type of deposit, glacial deposit, is called escarres. They are the long winding ridges of sand and gravel that run in the same direction as the glacier. They are deposited by meltwater streams following these tunnels under the ice. When this glacier retreats, the streams dried up and this load remains as an escarre, that elevated topography. So, now see we have glaciers, and from this glacier, due to tunneling effect, some streams are coming up, and once the streams coming up here, so they are transporting sand and gravel with that. So, now once the glacier retreats, these sand and gravels which are transported by the stream, they remains as it is. So, that means it is creating a locally positive topography, and you find these are these escarres. So, here you see number of escarres are there, that means this number of interconnected channels they were coming up from this glaciated region. Then cames, these are these ice contact stratified drift features deposited at the vicinity of melting ice and partly shuttered by water. So, that is mostly it is partly glacial and partly fluvial. Cames are these mound like hills composed of sand and gravels formed as meltwater streams on the surface of this ice plunge down crevasses, taking sediments with them, form accumulation of materials in the crevasses left behind when ice is melt. So, these are these areas where crevasses were formed in the ice. So, through these crevasses the streams are moving down and taking the sediments with them. So, once the glacier is melt, so these crevasses where through the stream was deposited, they remains there at the depositional form. So, composed of sand and gravel and till that accumulates in a depression on a retreating glacier, and it is then deposited on the land surface with further melting of this glacier. It is from taken from Wikipedia. So, these are these cames. So, then later on the most prominent one is the varp. Varps are found in the deposits of glacial lakes. Each varp consists of two distinct layers of sediment, a lower layer of light color and sandy material, and the upper layer is dark silt. So, this light and dark, they are indicator of different seasons of an year. The light color that is deposited during the summers or this melting of ice where the water velocity is more, mostly sandy, pebbly or gravelly, and the other one, the dark one, it is the represents the winter one, where there is there will be that means death of organisms due to severe winter. Most melting of this glacier occurs in the spring and early summer, so that these times the meltwater streams flow fastest and carry their greatest load. Fine material is held in suspension in the lake, whilst the heavier material is deposited. As autumns and winter approach, the capacity and the competency of these meltwater streams is reduced, because there is less melting in the ice. So, that means each alternate dark and white layer, this indicates summer and this indicates the winter one. So, totally they represent 1 year. This allows this finer material that has been kept in suspension and settle down and deposited. Thus, each year a new set of coarse and fine beds are formed. By counting this number of black and white or this dark and white combination, we can age that how much age is the lake, that is this glacier lake. For example, if you see in this figure, it is given, it is representing 1 year. So, this representing this winter and this representing the summer one, and generally the summer one is thicker as compared to the winter one due to this water scarcity in the winter. So, the varying thickness of these barbs provide the information about the climatic condition. Thick barbs are the result of increased deposition caused by warmer temperature and increased melting. Thin barbs suggest little deposition because of the reduced melting of water. So, analysis of this organic debris extracted from the barbs can also provide the information about this plant type existing at the time of deposition, giving more information about the climatic conditions. So, these barbs, they are good indicator of climate. Now, another type of deposit which is very peculiar in the glacial landforms, that is called drop stone. Drop stone, the name itself says it is dropped, not deposited by this water or the glacier. It is dropped means, suppose we have a lake where these glaciers, pieces of glacier, chunks of glacier, they are floating. If we have boulders embedded within that, by melting of the glacier, these boulders they drop down, and these dropped boulders, they are embedded within that glacial barbs. So, these are called drop stones. So, that means the name itself it was dropped from the glaciers. Now, what is the significance of the glacial study? Why we need a glacier environment study? First is glacial inversion modeling of continental scale. Paleo ice sheet is now recognized as an important tool for paleogeographic study or paleoglaciological study. Existing paleoglaciological reconstruction of this dimension, geometry and dynamics of former ice sheets are based mainly of the glacial depositional as proposed to the glacial erosional landform. So, that means by looking this erosional landform, depositional landform, types of erosion, types of deposition, we can reconstruct, we can restructure how this ice sheet was moving, where this accumulation area, where the retreating area, which path this glacier was moving through, like that. Investigation of this relationship between glacier meltwater channels and other aspects of the subglacial drainage system, such as areas of ice bed contact, areas of ice bed separation and precipitate field depressions, enable reference to be made concerning former subglacial water pressure drainage relationship, effective pressure and the glacial velocities. So, that means all these depositional or the erosional landforms that can tell about this nature of the glacier, where it is moving, where this more pressure was there, or less pressure was there, thickness of the ice sheet there, thin ice sheet there, small valley glacier there, where the sharks, scories and other glacier related materials or glacier related topographies are there. So, based on that we can reconstruct the paleogeography, we can reconstruct the paleoclimatic history. Meltwater paleovelocity and paleo discharge can also be calculated from this measurement of the channel shape, channel width and size of the material transported with former glacial meltwater channels. So, that means paleoglaciofluvial environment can also be reconstructed through this type of studies. Exposure age dating techniques including cosmogenic isotope dating of the bedrock surface will be important in increasing our understanding of this age and chronological significance of the landforms of the glacial erosion. These verbs can be dated, these sediments can be dated, this surface glacial surface can be dated. So, that we can have these chronological constraints when the glacial age, when the ice age was there. So, that means it is improvement of science, improvement of this knowledge regarding this paleoglaciology, paleoclimatology. Landforms of glacial erosion are of great value in ice mass reconstruction and speculate that these landforms will archive greater recognitions with paleoglaciology and line with improvement with exposure age dating techniques. So, with the help of age dating techniques we can constraint the climatologies, we can constrain the chronology of the glacial systems. So, I think it is the end of this topic. So, thank you very much, we will meet in the next class.